Okay, the next step in this project is I got to make a bushing to adapt the impeller of this machine, which originally had a 1-inch shaft, to this shaft here, which is 750, and actually I mic'd it. It's about 749, so it's a thousandth under 750. So what I'm going to do in a couple minutes here, I've got a piece in my lathe of 01 steel, which is it's heat treatable, although I'm not going to heat treat it, and it's a 1-inch OD piece of stock, and it fits real nice. It fits really nicely into the impeller, which is a 1-inch hole, so I won't even have to do anything to the OD of that. So I'll just in a couple minutes I've thrown it in my lathe, and I'll bore the piece. I'll drill it to a rough size, and I'll use a boring bar and bore the internal to make a real nice fit onto the shaft, and then I'll do a little adapting to make the some provisions to key the bushing to both the impeller and to the engine. So okay, I've got this piece of 01 chucked up in my lathe here, and at this point I've got a center drill into the tailstock, into my drill chuck, and what I'm going to do shortly here is I'm going to take a light facing cut on the front end of that bar, and that'll make the drill start very true. And after I center drill it, I'm going to step drill it up. I'll probably start with maybe a 3/8 bit, go to 1/2 inch, maybe 9/16, then 11/16, and that'll get me real close to the 3/4, and then from that point I'll start boring it till it's a real good fit, because I could just drill it, but drilling tends not to be the most accurate way to put a hole in something, so I want to size it so it's good. So I'll use the boring bar, and that way I can creep up on it and get it to a real good slip fit, and at that point I'm going to make some I'm going to drill some holes in it and use some set screws to act as a key, and key it to the shaft. So in a couple minutes I'll turn this lathe on and then do the boring. Okay, I'm getting ready to do the facing cut on this, and I've got a little tool chucked into the cross slide. I'm going to only take about 5 or 10 thousandths off, because the face of this isn't too bad, and that's all I need to get a nice true surface. So that'll be good. Next thing, I'll spot drill it, and then I'll start my step drill. I've got my center drill into position here, and this 01 is good material. It's some people call it ground stock. It's oil hardenable when you heat treat it, although I'm not going to heat treat it now. And the only problem with it is if you get too impatient or too ambitious with your cuts, and you go too deep, or you have a dull tool or whatever you're doing wrong, it'll heat treat as you're machining it, and then you're screwed. A lot of times you can take a piece of or a carbide bit and machine away the hardened part if you're lucky. But you gotta take your time and go slow with this stuff. But it takes a nice cut, and it's good quality steel, so that's what I'm going to use. Alright, so now I got a nice starting point to start my drilling, so I'm gonna step it up in a few different cuts, and then I'll do the final. I'm gonna start with the 5/16 drill. I'm gonna put a little bit of this Tapmatic drilling lubricant on here just to help it go a little bit. It'll probably smoke a bit, so we'll see what happens. Okay, I got my half-inch drill chucked in here now. It's a little cool out here today. It's 40 degrees in my garage, so it's a little cool. Not too bad though. Nice day. Okay, I'm going to go in with my 5/8, and then the final drilling is going to be an 11/16. I made a quick trip to the grinder because these drill points were less than good, so I smartened them up a bit. So I don't want to burn through this piece in any way. Okay, I got my 11/16 drill now. This will be my final drill. That's 687, so I have a 16th more to take out after I drill it, but I'll do that with a boring bar, and that way I'll be able to sneak up nice on the exact side I need so the bushing will work good. So give this a shot here. Okay, at this point I've got the slug parted off from the bar I was using, and through the magic of video I just did that because it's not that interesting to see. And I've got my boring bar clamped into my the holder in my tool stock here. And now if I had a little bit more things here, I would probably take a 3/4 inch reamer and finish this off, but I don't today happen to have a 3/4 inch reamer, and I also don't happen to have a boring bar that's sturdier than what I have here. So I got to go about 2 3/4 depth. So what I'm going to do is I'm going to do the one side, then flip it around and finish it off from the other side, and I'll just take careful consideration of my my sizes when I do that, and this will work out pretty good. This lathe I have here, I work on a really nice lathe at work, and when you work on something like this, it's you know, it has its drawbacks. However, for a piece of equipment sitting in my garage here that I can run out and make parts and everything else, I use this lathe all the time. It's more than adequate. It doesn't have great rigidity on the cross slides, and sometimes it especially with a heavy cut, it tends to chatter a little bit. But for what I'm doing, it works very well, and knowing those limitations, I can usually work around it. It does have a power traverse on it, so that works pretty good, and I'll be using that to do the boring here. So what I'm going to do is I'm going to start the boring bar, do a little bit, then I'll finish it up, and we'll take a look at it. Okay, I'm going to start in a minute here and take about a 30/1000 cut. Now this cross feed on the good lathe, if you want to take a certain dimension off a diameter or an interior cut, you dial it directly in, because each graduation is actually 1/2 thousandths in feet, and it takes 1/1000th off the OD. This one, when you turn it 1/1000ths, takes 2/1000ths off the OD or ID, whatever you're doing. So you have to just keep that in mind when you're doing it, but it's no big deal. Now I'm going to be using the power feed on this. It takes a nice cut, you know, it's a nice even chip coming off there. It's not screaming or anything, so it's not bad. I'm just using some WD-40 for the cutting fluid. Tends to work almost as good as anything else. It works very well on aluminum, actually, and keep the aluminum from sticking to your cutting tools. But I'm not taking such heroic cuts here that I could probably even do it dry, but it doesn't hurt to have a little kind of lubrication on it. I'm going to take a, I don't know if you can see this, I'm going to take a measurement here, and it's about 729, so I don't have that much more to go. And instead of going to a measurement, what I'm going to do is I'm going to take a few more thousandths off, and then I'm going to test it and sneak up on it till it fits rather than go to a dimension. Yeah, I'm getting about 729 there. So I'll come back in a little while after I finish. Okay, this is going to be the final final cut on the board of this thing, and I switched to a high-speed steel tool that I've just freshly sharpened, and I've got a very slight radius on the tip of the tool, so it puts down a nice surface finish on the inside of the board. So after I do this, we'll take it over, we'll try it on the shaft, and then I'll be doing some more work on this thing. This is a very light cut. I'm probably taking 1/1000th of an inch off at max. I didn't want to use the high-speed tool for the entire job because the carbide boring bar, if the material tends to harden or something, the carbide tool tends to go right through that, whereas the high-speed tool will probably round off, and then it just compounds the problem, and you end up heat treating the thing hard, and you're kind of screwed. but it's good. It's a nice sharp tool, and it'll give for final pass. It'll give a nice finish. Then I'll chamfer the OD and the ID of each end, and then face it off to the exact length I need. Okay, that's going to be my final pass down. There's a pretty decent surface finish inside there. So I'll take it out of the lathe and bring it over to the machine and test fit. Okay, this is the bore of the impeller, and I've got the my bushing here, and this is it's a real nice comfortable fit in there. It slides right in with virtually no play. So all I got to do is trim about 100 thousandths off that, and that'll be good to go. And as far as the machine goes here, whoops, it's a nice comfortable fit on the shaft there, and I'm pretty happy with this, so I'm gonna call that a success. Okay, what I've got at this point, I've taken the sleeve I made, the bushing, and I've carefully drilled and tapped 3 /4 holes in the top to allow me to put 3 set screws in. And on the set screws, I've turned the bottom portion of them down to about 186, 185 to accommodate the 3/16 shaft in the motor bore, or on the motor shaft rather. And then the top part of the set screw I left alone because the slot in the impeller is 1/4 inch. So what this is going to do now, I can load this into the impeller now. It locks in, and I can slide that right on the motor now, and that'll act as a keyway. Was going to weld this into this, but I don't think I'm going to, unless I have some kind of problems with it loosening it up, which I don't anticipate. So what I'm going to do now is take those set screws and lock them in with a little high strength Loctite, just so they don't move. Although once they're in there, they can't move. But I'm going to do that, and then take the impeller, and I'm going to sharpen all the cutting surfaces and do some reassembly on the machine and try out the new